Hi ZKJM everyone, this is Khushi from ZK Verify, and in this video I'm going to demonstrate to you how you can get started with ZK, that is zero knowledge based applications. First up, we'll talk about what does the architecture of a ZK app looks like, and then we'll move to how you can get started and like how you can basically write your first ZK circuit with no R. One more thing I want to mention is that these video series is a part of Zero Doubt, the ZK Verify India Workshop Series initiative. So in case you have attended any of our IRL workshops, this video is going to be a very great resource for you to either, recap the basics, or maybe you can use these as a supporting material to get started as a developer. No matter if you have a Web3 experience or not, but like this videos will help you equip with zero knowledge apps. All right. So first up, let's basically talk about what is the basic difference between Web2, Web3, and ZK applications, because this is something that actually makes a lot of sense to you. In our workshop series, we had variety of people, full stack developers, even the full stack Web3 developers, and even the developers with little coding experiences. So these videos are like created to cater all these personas in mind. So even like if you are equipped with the basics, you can skip to the next video that is about the hands-on ZK circuit writing part. But like if you're new, if you want to just brush up your basics, this is the video best for you. Now, if you talk about Web2 apps, the mental model is very simple. You have a front end, you have the back end, you have the API calls that goes between them. You use databases or any cloud vendors and the hosting services. So like in Web2, you can have different JavaScript or Python-based frameworks and languages to build your own application, whether it's web-based or Android-based. And this is how the basically stack goes. So if you are like equipped with the knowledge of full stack development and how the internet works, you're good to go with this part. But now in Web3, like there's like one additional layer which gets added on top of it. So like instead of relying on any centralized cloud vendors to execute your services, or maybe use these as the infrastructure, you switch to blockchains as the core infra to support your applications. So as a small recap, you have a user that connects with a wallet. It could be through Privy, MetaMask, Wallet Connect, Rainbow Kit, or things like that. So basically, in a simple Web2 app where you have the Google-based authentication, there's no wallet created. In the Web3 apps, you usually either connect wallet or you use the providers like Privy.io that actually is like supported by most of the Web3 applications. Now on the front end, you have all these Next.js based and JavaScript based frameworks which you can use, and this entire application, it interacts with the blockchain through the smart contracts, which can be written in Solidity, in Rust, or like in any other languages like Viper. You have various blockchain networks. It could be the Ethereum based or the Solana based environments where the execution actually takes place. You also have the storage systems in terms of the decentralized storage, and yes, indexers data, and the external oracles to fetch data from the any external resources to your application. Now, if you already are well equipped with how the Web3 applications work, very great for you. But again, if you are like not a Web3 native person, you can just try to understand it on a very surface level, because the focus for today is entirely on the beginner's ZK application. Now, this is where you need to have your focus today. So, when we talk about the applications that use zero knowledge proofs, this is the mental model that you actually have to understand. First up, you have this user that interacts with the user application. This user application can be a web app, it can be a mobile client, or it can be a decentralized application front end. Now, just know that there is a circuit layer which is the part of this application. Now, what does this circuit layer do? It defines constraint. So we know that ZK proofs, they are like, they like, if you talk about it, basically when you create proof, you basically have to write your own circuit is a piece of code that helps you define the logic for your proofs, and then essentially run it, compile it, and do some things with that. So the circuit is basically the code that contains the logic which will be the foundation of your proofs that will be created further. For example, let's take an example. Suppose we made an age verification system. Like we have created a verification system with ZK that only lets the user who are 18 plus access the website, or maybe identify if the user is above 18 or below 18. Now, if we are going to write the circuit for this particular logic, our constraints are definitely going to be about checking if the user input, that is the age of the user, is more than 18 or lesser than 18. So like you define these type of constraints in this particular circuit layer. You have multiple ways you can write it. You can use Noir for the ultra Planck proof types. You can also use Circom, which is like for more like uh, you know, a little more complex proofs. And you can have Halo 2, you can use Cairo, which is supported by Starknet to, write these circuits. Another way to think about the circuit layer is definitely going to be, you must have written a lot of Python, Java, or C++ programs where you do things like write a program that checks if the user is eligible to vote or not. So what is exactly the logic in that program? You check for the age, you define the constraints, the conditionals, you use the operators and define it all. In the similar manner, you are having those similar constraints in this particular circuit layer. So the difference is like not very vast, it's pretty simple. Now, then you have the witness generation. Now, I have this user who is like going to work with these applications. So like when there's a trigger that you basically, have to check for the circuits whether this logic meets or not, you are definitely going to need the witness generation. Now, witness generation is simply about taking the private and public inputs which are assembled off chain. Like we are talking about off chain verification here, so definitely the witness generation is going to be taking place off chain. Now, witnesses, they are the set of public and private inputs. And we will talk about it later, like how you can actually fetch them with a hands-on demo. Now, once we have the circuit, which it has defined all the constraints of the application, and we have the witness that is like private and public input. Example, my circuit layer talks about the logic to see if the person is 18 plus or not, and my witness is going to have the private and public inputs. That is the user's actual age, which will be received by the system. Now, in the third step, we generate proofs. So there's a prover which can either run locally, or you can either also do it through other proving networks. But again, we are talking about off chain, so it's going to run locally. And the proof, a mathematical proof, will be created, which is more like a combination of the constraints that are defined in the circuit layer and the witnesses that we have with us. Now, this proving network is like pretty optional because again, we are talking about the off-chain verification stuff. So along with when the proof is generated, you also have a proving key, which is which appears, and then you also have a verification key, which is essential for the ZK application, and this verification key will be used further by the verifier for the further verification process. Now again, on the verification layer, you can use any custom verifier node or TE based verifiers. Now what the verifier does is that it checks if the proof was generated in a correct manner, more like if the proof was generated with the right logic, the constraints were correct, there was no fault during the generation, and that is done with the help of verification key. So like think of it like this: you have a verifier is going to run a mathematical function, and that mathematical function is run on two parameters. One is the verification key, and second is the proof, which is generated from this particular step. Now, when the verification process is completed, you basically, like, there is a response which is actually cryptographically signed, and it is returned via hook. So you call it like a signed attestation that okay, the proof was generated, the proof was verified, and now it's being sent. And now this attestation in terms of off-chain verification will be sent back to the application logic. It could be the backend, it could be the server, it could be the traditional centralized storage as well. But again, it's only for the example purpose right now. So this is basically how your ZK app work. As a small summary, you have an application which can be a web-based or any mobile-based app. it has a circuit layer. A circuit layer is basically the code where the the circuit is actually written. So this code can be written in languages like Circom, Noir, or Cairo. Now, you also then, like after this, you have some witnesses, like there's a witness generation that takes in the public and the private inputs, taking up the circuit layer constraints and these witnesses, the proof is generated. Along with that, we also have a proving key and also a verification key. Now, in terms of off-chain verification, that is the verification which is not taking place on any on-chain environment, you have this verifier where it runs a mathematical function to see if the proof was generated in a correct manner. And now during all this process, the data is like, I would say it's not decrypted or not decoded in any manner. After the verification is successful, there's an API response that sends the signed attestation to the application logic in terms of the off-chain verification. Now, so I hope that the information so far about the off-chain verification through the ZK apps was sufficient for you to equip and get started with the workshop that we are going to do, in a very beginner-friendly format. So after this, you have to watch the next video where you will learn how to write your first circuit with Noir and basically how the architecture of a simple ZK-based application can look like.